Okay, number 1 asks us about the rock, paper, scissors game. So let's get all possible outcomes. So we have player 1 and we have player 2. So the player 1 could have a rock and player 2 could have rock, paper, or scissors. If player 1 chooses paper, the player 2 could be rock, paper, or scissors. And this one could be scissors, and they could do rock, paper, or scissors. Okay, so that's our total number of outcomes. Okay. Find the probability that player 1 wins on the first throw. Okay, so this would be a tie. Rock, paper wins, so rock, paper. Okay, paper covers the rock, right? Okay, so number 2 wins. Rock beats the scissors, so player 1 wins. Paper covers the rock, so player 1 wins. Paper is a tie. And the scissors cuts the paper, so player 2 wins. Okay, and then here, the rock wins, so player 2. The scissors gets the paper, so player 1 wins, and this was a tie. So we have this is part A there. Part B, what's the probability that player 1 wins? Probability that 1 wins. Okay, 1 will win 3 out of 1, 2, 3, 4, 5, 6, 7, 8 out of 9 times, a third of the time. Okay, so that's the first problem. Number 2, humans either have type O, A, B, or AB blood. And here's the distribution. It varies by race. This is typical Black American, distribution of Black Americans. So we have O, A, B, and AB. So what's the probability that they have type AB? It's missing here, right? But if these are the only possible outcomes, I know that all these have to add to be 1, right? 100% of the data is going to be one of these things. So 1 minus this, minus this, minus this gives us 0.04. So only 4% of the Black U.S. population has type AB. Okay. Part B, what's the probability that the chosen person does not have type AB? Well, if 4%, 1 minus 4% would equal 96. Or you could add these together. 0.49 plus 0.27 plus 0.20 would also equal 96%. Okay, so either way you can do it. Complement's the easiest way. Okay, question number 3 was, in government data, household consists of everyone who lives in the house. So if we choose an American household at random, here's how many people live in those houses. So 1 person, a quarter of the houses only have 1 person living in them, and 2, 3, etc. 7 plus people, only 1%. Okay, so it says the probability of finding 3 or 4 are the same, so these numbers are the same. So how do we find what those numbers are? Well, if I take all of them, they have to add up to be 100%, so 1. So 1, if I subtract these other 5, I get 0.32, and since these are the same, I divide by 2. I know that both of them have to be 16%. So altogether, that will add up to be 100%. Okay, so both of them are 16. Part B, find the probability that the chosen household contains more than 1 person. Okay, so the probability of more than 1. Okay, I could add all these together, or let's just do 1 minus the probability of only 1. So more than 1 would be 75%. So I could either add all these together to get 75, or 1 minus this will give me what all those are. Okay, number 4 is talking about the blood thing here we had. So she has type B blood, and she can only get a blood transfusion from type O and type B. So what's the probability that she can get a blood transfusion? So from type O and B, so probability of O or B. Okay, you can't be both A, O, or NB, so they're mutually exclusive. So all I have to do is add those two together. So 49% plus 20% gives you 69. So there's a 69% chance, if I just pick a random person, that this is black U.S. Americans, that she's going to be able to have their blood transferred into her. Okay, number B, letter B. Find the probability that the random chosen black American cannot donate. Okay, so easy. Let's find the probability of the complement. Okay, so if we chose this as A, we'll do the complement. So 1 minus 69% would be 31%. Okay, that's the easiest way to do that. You could also add all the others together, but it'd be easier just to do the complement. Okay, for the last one, it says that if we pick a random person in their 20s, 25 to 29, what it says there's probability that 13% of them would have not a high school degree. 29% of them would have completed high school but no farther education. 30% of them have had high school and have earned a college degree. And then there's some of them that have earned a high school degree, but they went to some college but they didn't finish. They have some college degree. It's not degree, but they have some education. So what's the probability of this happening? Okay, we know that all these have to add up to be 1. So 1 minus 13% minus 29% and 30% gives us 28%. Okay, so we know that 28% of the people were fit in that category. Part B says, find the probability that young adult completed high school. Okay, if they completed high school, okay, probability complete high school. Okay, you could take this one and this one and this one and add those all together, or 1 minus no high school would be 87%. Okay, that's the easier way to do it using the complement rule. Part C, find the probability that the young adult has farther education beyond high school. Okay, beyond high school would be these two categories. So this is no high school and this is just high school. So beyond high school, probability of beyond high school would equal 0.28 plus 0.30, which is 58% of the people have gone or some sort of education beyond high school. Okay, that's your homework.